Hello viewers, in today's class we are going to discuss a very important and very interesting problem from definite integrals involving modulus function, right? And this problem is going to be very easy and interesting, right? So let us see how we can solve this integral containing three functions, right? That is three mod functions. So here we have to find the integral from 2 to 3, and the integrand is the sum of three functions: mod of x minus 1, mod of x minus 2, and mod of x minus 3, right? So here I will see how easily, by making use of the definition of mod function, we can first simplify this function, and then we can readily get the desired answer, right? So let us start. So let us first call this integral as I, right? Now see, whenever we get these type of integrals where we have more than two mod functions, usually what we do is to get the sum of three integrals, right? So some learners can do it like this, that is 2 to 3 mod of x minus 1 dx plus 2 to 3 mod of x minus 2 dx and 2 to 3 mod of x minus 3 dx, right? And then by separately calculating the value of each integral, we can add up the three values and we can get the desired value, right? But here we are not going to adopt, or we are not going to use this method, but what we will do, will consider this entire function as a single function, right? So what we will do, we'll take this entire integrand as f of x, right? So this is mod of x minus 1, mod of x minus 2 plus mod of x minus 3. Now we'll try to redefine this function within the given limits, right? So we'll redefine this function within these limits. So the lower limit, let us say it as a, and let us say it as b, right? So the lower limit is 2 and the upper limit is 3, right? So our x belongs to the interval 2 to 3, right? So now what we will do, we'll first see the definition of mod function. So now see, mod of p is defined like this. So mod of p is positive p whenever p is greater than 0, right? And mod of p is always 0 whenever p is equal to 0, and mod of p is negative of p whenever p is less than 0, right? Now see, will what we will do, will apply this definition to each of these three mod functions, right? So let us first see a mod of x minus 1, right? Now see, when x belongs to this interval, that is 2 to 3, right? So obviously every value of x must be greater than 2, because x belongs to 2 comma 3, right? So mod of x minus 1 must be positive x minus 1, right? Why? See, let us take for an example any value lying between 2 and 3. Let us take x is equal to say 2.5, right? And if we take this 2.5 and we calculate this difference, that is x minus 1, this is an easy method to get the sign of mod of x minus 1, right? Whether it would be positive or negative. So let us take x is equal to 2.5. So 2.5 minus 1 is 1.5, right? And 1.5 is obviously greater than 0, right? So p is greater than 0. So it means the term which is inside these two lines should be positive, right? So this is an easy method to get the sign of mod function, right? So mod of x minus 1 is positive x minus 1 whenever x belongs to 2 comma 3. Now let us take the second term. So here we have mod of x minus 2, right? And again, let us take this, or let us take this point, that is x is equal to 2.5 in this expression, that is x minus 2. So we'll get 2.5 minus 2, right? So 2.5 minus 2 is 0.5, which is positive, that is greater than 0, right? So mod of x minus 2 is again positive x minus 2, right? So this is a quick way to get the sign of this mod function, right? Whether it would be positive or negative, right? Now let us take mod of x minus 3, right? And again take this testing value as x is equal to 2.5. So x minus 3 is 2.5 minus 3. So obviously 2.5 minus 3 is the negative of 0.5, and this is negative, that is less than 0, right? So mod of x minus 3 should be negative of x minus 3 in this interval, that is 2 comma 3. So here the limits of integration are from 2 to 3, right? So now this function f of x can now take the form mod of x minus 1 is positive x minus 1, then mod of x minus 2 is positive x minus 2, and mod of x minus 3 is the negative of x minus 3, right? So this is an easier method to redefine a function containing more than one mod functions, right? So this is x minus 1, this is x minus 2, and this is minus x plus 3, right? So now we have got rid of this mod sign, and we have now x minus 1, x minus 2, and minus x positive 3. So here we have x plus x, 2x, 2x minus x is x, and here we have minus 3, minus 1, minus 2, this is positive 3, so 3 and 3 get cancelled, so we are left with x, right? So the function f of x, or the integrand, this f of x is equal to x when x belongs to this interval, that is 2 to 3, or x is greater than 2 and less than 3, right? So viewers, now our integral I can be written as 2 to 3, and this function is equal to f of x, that is equal to x, right? So here we have x dx. So now this is a very simple integral. This is x raised to 1, and we can apply this rule, that is x raised to n. The integral of x raised to n is x raised to n plus 1 divided by n plus 1, provided n is not equal to minus 1, right? So this is an important thing here. So 2 to 3, x raised to 1, so this is x square over 2, and the limits are from 2 to 3, so this is 3 square over 2 minus 2 square over 2, substituting the limits and taking the difference. So here we have 9 over 2 minus 4 over 2, so this is 9 minus 4 over 2, that is 5 over 2, that is 2.5, right? So the value of this integral is equal to 2.5. So viewers, this is how we can solve these type of problems containing mod functions by first redefining the integrand by this method which we have discussed here, right? So this is how we can solve these type of definite integrals.